Hello, good afternoon, and welcome to another episode of Physics with Japi. And for today, we're gonna be talking about vectors and statics. Okay, so I guess it's more of statics, right? The problems are statics, but we're gonna be solving, or we're gonna be using vectors, or the way how to solve vectors in these kinds of problem. Okay, so let's see first. Okay, so first off is this one. Let's read the problem first. I hope you guys are excited. It's been a long time since we uploaded. Okay, so for example, a 10 kilogram mass of an object is said to have a weight on Earth that is 6 times than the weight on the moon. Okay, so a 10 kilogram object has a weight. We can get the weight by multiplying by 9.81 meter per second square, and it is said that the weight on Earth is 6 times on the moon. Okay, so meaning we multiply the moon 6 times in order to get the weight of the Earth, or we divide the weight on Earth by 6. Right? If the moon is said to have 1,737 radius, determine the mass of the moon. Okay. Oh, wait a minute. This is not statics. Welcome to another episode of Japi with kinematics. Okay, so this is kinematics, but we're gonna be solving that for now, because from what I'm teaching, okay, weight is usually taught in statics. Okay, weight is usually taught in statics. Kinematics, we don't focus on weight. Okay, but since we have the weight of the mass on the Earth, 98.1 Newton, okay, and if we divide that by 6, that will become the weight of the object on the moon. Okay, and use by formula of F is equal to G m1 m2 over d squared. Okay, the way I memorize it is F is equal to gamma d2, R2d2, F is equal to gamma d2, okay, or d squared. Okay, so gravitational constant times 10 kilogram and the mass of the moon divided by 1,737 times 10 cube squared. 98.1 divided by 6 times 1,737 times 10 cube squared divided by G divided by 10 is equal to mass. Okay, what would be the mass of the object, or what would be the mass of the moon? Okay, 98.1 divided by 6 times parenthesis 1,737 times 10 cube squared divided by RG 6.67 times 10. Okay, I don't remember, but we can use 39. Yeah, I don't remember, but we can use 39 divided by 10. Okay, 7.39, 17 times 10 to the 22. Oh, you guys didn't see that. Okay, times 98.1 divided by 6. 1,737 kilometers. Divided by G divided by 10. I think that's right. 7.3917 7.3917 times 10 to the 22 kilogram. Okay, and that is the mass of the moon. Okay, next problem. Oh, we're done with the first problem. I hope solving this problem is not too fast or not too slow for you guys. If you guys have any question, you can just comment below on the comment section. You know, feel free to ask anything if there's any clarification, and if ever there is, you know, I'm gonna answer that. And plus, any future, you know, future watchers or future viewers will be able to see your question and will be able to know, or in advance, you know, or if there's like clarification, and in the next problems, we're gonna be able to do something about it. You know, if I'm not explaining very well some things or some stuff that should be explained when it comes to solving this kind of problems, especially physics. Physics is a very weird problem, especially this one is, I think it's very weird. Okay, because you know why it's very weird. Okay, it says that we have a given here. We have a weight of 800 pounds, right? We have normal force, you know, but there's no question. What's the question? There's an angle here and an NF here. I think the NF and the angle are the ones should be asked here. There's no question in this problem. Okay. Anyways, let's deal with this problem. Okay. First off, we have a diagram here. We have like in statics. Okay, we have forces that we put. First off is the weights of the object. That's the load. Second is normal force. Okay, tensile force. There should be a force here. Tensile force here, right? 200, 400. That's called tensile force because there are cords pulling your cylinder. Okay, tensile force. Compressive force. There's no compressive force here right now. What else? Compressive force, friction force. It says that it's a frictionless pulley, so there's no friction right now, and the cylinder is not moving, so I don't think there should be a friction here. Normal force, I think that's it. Okay, let's make an FPD diagram. NF. Okay, 800 pounds. Okay, an angle, forgive my very accurate drawing, 400 pounds, then 200 pounds. Okay, if we make an x component and y component of that, x component, y component, we do positive 0, positive NF, negative 800, 0 for the y-axis vectors, because the NF is facing upward and 800 is facing downward. It's positive and it's negative. Negative 200 facing leftward and 400. Oh, I'm just gonna put 0 for now on the 200 for the y component. Then 400 sine theta and 400 cosine theta on the x and y component. Okay, and it's in equilibrium because it's not moving. There's nothing said about it moving, and plus it's statics. We're talking about non-moving objects. Okay, first off, we're gonna do the x component. Okay, so 400 cosine theta is equal minus 200 is equal to 0. Transfer 200 to the right side. Math, algebra. 200, 400 cosine theta is equal to 200 cosine. That's a pretty small cosine theta. I'm gonna make my writing bigger. 200 over 400. 1/2 cosine theta, 1/2 is theta is 60 degrees. Okay. Unit circle. Identity. When the cosine angle is 1/2, it's 60 degrees. When the sine angle is 1/2, it's 30 degrees. Okay. So we can guess the value of NF. Not guess, or get. Negative 800 plus 400 sine 60 is equal to 0. Okay. NF is equal to 800 minus 400 sine 60. What will be the answer? Okay. Okay, so 800 minus 400 sine 60. 453.5898. 453.5898 pounds. And that is the normal force. Okay? That's pretty fast for an answer. Again, for in statics or in vectors, it is important for you to know to convert each of the following into weight by F equals ma, or if you're in another planet, F is equals to g m1 m2 over d squared, or the weight is equal to mass times acceleration due to gravity. Okay, but if the forces are already there, you need a diagram for the FBD. And also, you need to know where to put your friction, normal force, compressive force, and tensive force. Okay? You have your X component, Y component, you have your X component, and this is your Y component. Okay? Diagram, component method, algebra. Okay? Formula from physics. I think that's the most essential part. Doing a lot of FBD here. We're gonna learn about free body diagram. How about we take it slow? So, two blocks each weighing 1.5 kilonewton. Let's put one weight, right? A weight was downward, 1.5 kilonewton. 1.5 kilonewton by a uniform horizontal bar that weighs 1 kilonewton. Okay, weights are always at the middle or center of gravity, and weight is equal to mass times gravity. Since the weight is already in force, we don't need to multiply it. But if you're given a mass, we multiply it to 9.81 or 32.2. The angle of friction is tangent 15 degrees, so we're gonna use that. And find P directed parallel to the 45 degrees because impending motion to the left. So if this is motion to the left, friction, NF first, and let's name this NFA. Let's name this NFB. Okay. And this is like the physics part, where we're applying forces that are not shown in the diagram. And if friction here going to the right because motion is to the left, friction B. Friction to the right again because the motion is to the left, so friction A. Okay, we're applying forces that are not seen, right? AX and AY. If we're talking about the box, BX, BY and BX. If we're talking about the box, okay. So first off, let's do the FBD for the bar. Okay. At bar. For the bar, we have a downward force, 1 kilonewton. We have an outward force, BY. Upward force, AY. Okay, we basically write down all the forces that we could think of, right? Weight, tensile force, there's no cord, so it's okay. Compressive force, reaction, right? The EX or the BX and the AX. Okay. So in this diagram, we could see that the X component is AX is equal to BX. And 1 kilonewton is equal to AY plus BY. Okay. In this diagram. We could also do like a moment at A, that if the distance between the forces, the reaction is like X to X, right? 1 kilonewton, who's directly downward, positive, clockwise, is X distance plus BY, okay, negative BY, whose 2X distance is equal to 0, meaning 1 BY should be 0.5 kilonewton, right? And AY it should be 0.5 kilonewton. Okay, that's AY and BY. Okay, so how about let's do FBD at box A. Okay, so for FBD at box A, box A, we have AY, we have AX, okay, we have normal force. This is 30 degrees, right? 30 degrees. If this is 30 degrees, okay, this should be 60 degrees. Okay, friction was 30 degrees. The 1.5 kilonewton weight. Okay. Okay. And I think AY should be downward. Okay? Sir, why is AY downward but you draw AY is upward? Okay? First of all, AY is downward because the weight of 1 kilonewton is downward. And if it is subjected to the box, right? Yes, the reaction of AY when we're talking about the bar is upward, right? 0.5 kilonewton upward. So if we are talking about the box, the reaction of the bar will be 0.5 kilonewton downward. Okay, the box reaction, the bar's reaction to the box is it's pushing it downward. Okay, because of the 1 kilonewton weight. Okay, this is gonna be F. Okay, so let's do X component first. NF cosine 60 plus, I'm gonna use NF for friction. Tangent, formula for friction is fun. Mu NF, or in this case, F friction is equal to tangent 15 degrees NF. Okay, so NF tangent 15 degrees cosine 30, okay, is equal to AX. Okay, so Y, right? Y NF sine 60, okay, minus NF tangent 15 degrees, that's for the friction, sine 30, that's because it's looking downward, right, is equal to, or let's specify this as NFA. Okay, let's specify this as NFA. So NFA tangent 15 sine 30 is equal to 2 kilonewton. Okay, so we can get NFA here. NFA is equal to 2 kilonewton divided by sine 60 tangent 15 degrees sine 30 negative. Right? Let's see what would be the answer. 2 divided by sine 60 minus tangent 15 sine 30. 2.7320, 2.7321 kilo Newton. Okay, that's for our NFA. Okay, we can get the AX too. Substituting the value on this part, we can get AX. AX will be 2.7321 cosine 60 plus 2.7321 tangent 15 cosine 30. 2. AX is 2 kilonewton. Okay, let me double check. We use sine. Okay, I'm double checking this time. Okay, believe it or not, this is my second time solving this because I made a boo-boo on my first turn. Okay, my first round. How about let's do FB at B, right? Let's do FB at B. Okay. This is the B. FB at B. So we simply just write off the forces BY. I'm gonna put BY opposite because BY, okay, is more of a reaction by the bar, right, which is downward. Okay, there we go. BX to the right, NFB to the left, NFB to the left, 45 degrees. Friction to the right, 45 degrees. P to the left, 45 degrees. Okay. X component. So we got NFB cosine 45 negative, right? Positive NFB for the friction, tangent 15. Okay, that's the friction. Cosine 45, right? Right, next is minus P cosine 45 degrees. Then BX is positive 2 kilonewton. So if AX is going to the left, it's just good to say that BX is going to the left too. Going to the right or opposite side. Right? 2 kilonewton is equal to 0. We don't have the value of P and NFB. So we're just gonna move on for that. Y. Actually, there's two unknown here, right? So for Y, NFB sine 45 plus NFB. So this is for the friction, tangent 15 sine 45. Okay. Minus P sine 45 is equal to 2 kilonewton. Let's make that negative 2 kilonewton, right? Alright, we're gonna put that on our calculator. I hope I get the right answer this time. Okay, so on our calculator, let's just mode equation 5 AX plus BY is equal to C. So for first one is negative cosine 45 plus tangent 15 cosine 45 negative cosine 45 negative 2 sine 45 plus tangent 15 sine 45 negative sine 45 positive 2. I think that's supposed to be it. I think that's supposed to be it. I don't know what's gonna be the answer. I hope I'm right this time. Okay, negative cosine 45 plus tangent 15 cosine 45. Negative cosine 45. Negative 2 sine 45 plus tangent 15 sine 45 negative sine 45 2. Alright, let's make our answer pretty or correct, because we're gonna pass it on YouTube, so we must like make it understandable. This is supposed to be tangent 15, okay? There we go. So NF or NFB is gonna be 2.8284 2.8284 kilo Newton. I hope the dogs are, guys, if you want to know my nationality, I'm a Filipino, and just so you know, every Filipino has dogs, right? Or majority probably has dogs. And if you're hearing dogs on a streamer, on a YouTuber, he's probably a Filipino if you have dogs, because everyone loves dogs. And also cats, everyone loves cats. P is equal to 0.7578 kilonewtons. And we got it correct. This is the right answer. Let's go! Okay. So again, I'm gonna tell you guys what I told to the other 79. Okay? To the first part. This is my second time solving this. Okay? This is my second time solving this. And I got I didn't use my calculator. I didn't use my calculator that much on the first time, and I messed up a calculation. Okay, so this time we got it right. I hope you guys learned something, or you guys like, we made 3 FBDs at this problem. FBD at the bar, FBD at box A, and FBD at box B. Okay, and I'm thinking of another solution by using moment or torque. Let's see if we could use a moment or torque. But before I do that, I'm just gonna try it off stream. I'm gonna record it, but I'm gonna try it, and I'll add it to this video if I am successful. If not, okay, I'm gonna say goodbye. Thank you so much, guys. If you learned something, this is Japi teaching physics, vector, and statics. Okay, next one is gonna be kinematics. So I hope you guys learned something. Stay tuned. If you guys have any question, guys, if you guys have any question, feel free to comment below, and like and subscribe. Help me get some get some of you guys to watch more. Help me to helping you guys in your physics. Okay, thanks so much, guys. Bye.